So today's exercise is going to be sum total of all the learnings that we have done in this chapter, right? It's going to apply cross formulations. It's going to apply fundas that you have learned throughout the chapter, implemented in other exercises as well. And the culmination of everything would be used in this exercise, right? So the only tip that I would have for you guys before you start attempting this exercise is to be thorough with all the formulas and all the questions before this exercise. You should have completed them by yourself, and only then should you attempt this exercise, right? Because then you'll be able to. Yeah, so without wasting any more time, exercise 3.4, I guess, but that is the miscellaneous one, and we'll go on with the first question. Correct. So the first question, question 1 of this exercise, is that prove that 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 equals 0. Correct. This is something that you have to prove. Now, let us try and look at the LHS. It's very simple, or it's very trivial for us to observe that we somehow need to equate this entire term to 0. Correct. So that will only happen when these two terms, cos 3 pi by 13 and cos 5 pi by 13, negate out, right? They have a positive sign attached to them. So somehow I need to formulate this entire term to be the negation of these two terms, right? Somehow I need to apply some formula in this term, which would result in cancelling these two terms out. If that happens, then I'll be able to solve the question, right? So let us try and do that. Just by taking a glance at cos pi by 13 and cos 9 pi by 13, and the 2 that is multiplied, the constant 2 that is multiplied to this term, a formula should arise in your mind. Cos C plus cos D ka formula, isn't it? So cos C plus cos D is nothing but 2 cos C plus D by 2 cos C minus D by 2. Correct. Now, assume C plus D to be pi by 13. So C plus D by 2 to be pi by 13 and C minus D by 2 to be 9 pi by 13, or the converse, right? Because 9 pi by 13 is actually bigger than pi by 13. So assume C plus D by 2 to be 9 pi by 13 and C minus D by 2 to be pi by 13. Correct. If you replace these two terms here, you're going to get something, two separate cos terms. Correct. So when you try and do this, no, the formula that you'll end up with is cos A plus B plus cos A minus B is equal to 2 cos A cos B. Correct. So when you substitute this for something, and this, I'll try and do this for you, right? C plus D by 2 equal to, let's say, A. C minus D by 2, let's say, equals to B. Correct. So C plus D equals to 2A. C minus D equals to 2B. Adding these two terms up, I have 2C equals to 2 times A plus B. Does that make sense? Because these two terms cancel out. 2A, I've taken 2 common here. So C equals to A plus B. And this is the formula that I wrote for you guys, right? Correct. And similarly, when you do the same same calculations for the B, for B term, you'll get A minus B. Correct. So when you solve this, you get that. Let us try and use this formula for our specific question and see where we get it, right? See where that gets us. So in essence, this term then becomes cos pi by 13 plus 9 pi by 13 plus cos 9 pi by 13 minus pi by 13. Plus, we'll write these two terms as is. plus cos 5 pi by 13. Does that make sense? Because I've used the formula that I derived earlier in to change this term, and the thing that I ended up with was this right here. Correct? Let's try and simplify this. So cos pi by 13 plus 9 pi by 13, it's nothing but cos 10 pi by 13. Correct? Plus cos 9 pi by 13 minus pi by 13 is cos 8 pi by 13. Plus these two terms I'll write as is. Correct. So this is something that I ended up with. Now, doesn't seem to cancel out, does it? There is one slight change that you have to incorporate to cancel all these terms out. And you'll be able to do that, right? Just remember that this is where we ended up. And I'm going to rub this part off so I have more space to write solution. All right. I'll continue with the term below here. And let's see where that gets us. So can we write 10 pi by 13 as being equal to cos pi minus 3 pi by 13? That makes sense. I have done nothing, but I've represented 10 pi by 13 as being equal to pi minus 3 pi by 13. Correct. I've done nothing else. And similarly for cos 8 pi by 13, I'll do that again. I'll represent this as cos pi minus 5 pi by 13. And these two terms as this again. Correct. I've done this now. Let's try and move on from here. Drop this part off. Now, we know that anything that could be represented as cos pi minus, let's say A, is minus cos A. And why is that? Because this term lies in the second quadrant, right? If you envision this circle, right, and this is the, sorry, this right here would be pi, correct? This is 0, move the anti-clockwise direction. So this is pi. Anything north of here is in the second quadrant, right? Subtract anything from the pi and land up in the second quadrant. In the second quadrant, cos is negative. So this in essence would reduce to minus cos 3 pi by 13. And this, using the same formulation, would reduce to minus cos 5 pi by 13. This entire exercise might seem very tedious to you right now, but trust me, if you do this, you'll be able to, articulate your answers much better. 3 pi by 13 plus cos 5 pi by 13. Correct. I've written these two terms as is. Now this cancels. Sorry. This cancels with this. This cancels with this, equates to 0. That is our RHS, and the question is solved. That makes sense. Now, why have I taken the effort to actually derive the formula for you guys? I have done that because this is the first question of this exercise. Moving on, I'll just write the formula and you guys should try and derive that for yourselves. That is a practice that you guys should incorporate, right? I'll write the formula. I'll tell you gist of how it came, but you guys should try and do that for yourselves. This was the first question, so we went as deep as we could, but we will try to pick up the pace as we go on, right? Moving on to the second question. Question number 2. Now, question number 2. This is a good one. Sin 3x plus sin x plus cos 3x minus cos x equals to 0. This is something that we have to prove. Correct. Let's try and do this. In this entire question, the application that we have to incorporate is very simple. We just need to use sine or cos c plus d formulas, right? Formulas of the form sine c plus sine d equals something, or sine c minus sine d equals something, or cos c plus cos d equals something, or cos c minus cos d equals something. Those are the formulas that I hope that you guys have learned, because these have been used in the exercise previous to this, and this exercise won't be any different. It's just going to use the formula that you have learned earlier, right? let us try and reduce this term to something, correct? So what is the formula for sine C plus D? What is the formula for sine C plus sine D? Sorry, I misspoke. What is the formula for sine C plus sine D? Sine C plus sine D equals 2 times sine C plus D by 2 cos C minus D by 2. At this point, you guys should have memorized this, right? This should be this should be at the tip of your tongue, so to say, right? So I'll try and write that. Let's try and simplify LHS. 2 times sine C plus D 3x plus x equals to 4x by 2 cos 3x minus x equal to 2x by 2 into sine x, correct? Do the same for the cos plus cos C minus cos D. Cos C minus cos D is nothing but minus sine minus 2 times sine C plus D by 2 sine C minus D by 2, correct? So at the earliest, I'll replace the positive sign with a negative sign because this term leads to a negative sign, right? So I'll replace that. I'll do that. C plus D sine C plus D by 2. So 3 plus x, 3x plus x equal to 4x by 2. I'll write that sine 4x by 2 into sine 3x minus x equal to 2x by 2 and the cos term in multiplication. That makes sense, correct? Let us try and simplify this. So this term then becomes 2 times sine 2x cos 4x by 2 is equal to 2x cos x sine x, and this term becomes 2 times sine 2x sine x cos x. Does that make sense? Cos 2x by 2 equal to x and cos x as is. This term gets cancelled, equals to 0, and that is nothing but our RHS, correct? So we have proved this as well. This was very trivial application of the formula sine C plus sine D or cos C plus cos D. And you just have to remember the formula to get there, right? You'll get there with practice. If you at the moment you think that the formulas are not, you're not able to recollect those formulas as fast as you would like ideally. So just try and practice it more and more. And at a certain point with practice, you're going to get there, right? That is the only way you're going to remember these formulas. Moving on to the third question. Third question says that we need to prove that cos x plus cos y whole square sin x sin y whole square equal to 4 cos square x by 2, correct? This is something that you have to prove in this question. So how are you going to do that? First of all, let's start from LHS and we'll arrive at the RHS term as well, right? Equals to this. And so how are you going to do that? You might be tempted to kind of expand this whole square term, right? You might be tempted to open this up and try and formulate that. If you do that, you're going to arrive at the answer nonetheless, but that is going to be slightly tricky for you and slightly time consuming for you as well, right? Because it's going to involve a lot of changes that you are going to have to make eventually, right? Rather than doing that, take a look at the RHS term. The RHS term is expressed in the formulation of x plus y by 2. Inside the cos function, the term is x plus y by 2. So why not, before squaring these terms up, let me simplify the term that is inside the bracket. Let me simplify this and this, correct? And then I'll square up and let us see where that gets it, right? So cos C plus cos D is nothing but 2 times cos C plus D by 2 and cos back cos by 2 plus sin C minus sin D. It's nothing but 2 times cos x plus y by 2 sine x minus y by 2. Correct? The whole square. Correct? Makes sense? Now it will help us if we square these two terms up, and let's see where that gets us, right? So I'm left with cos square x plus y by 2 cos square x minus y by 2 plus 4 times cos square x y by 2 square by 2. Correct? Notice that 4 times cos square x plus y by 2 and 4 times cos square x plus y by 2. So we had to prove something of the sort. This entire term we had to prove as equating to RHS, right? So this term, if you see it properly, could be taken out common from both these two terms, right? So when I do that, what do I get? Let's try and write that. Just remember this. I get 4 cos square x plus y by 2 as common, and the bracket I get cos square x minus y by 2 plus sine square x minus y by 2. This term right here is an identity. Cos square theta plus sine square theta equals to 1. So this can be written as equals to 1. And so the LHS term that we get is 4 cos square x plus y by 2. That is equal to our RHS as well. And hence the question is proved. Yeah. So the thing is, when you try to solve this question, just try and first look at what the RHS is, right? If you had first expanded without kind of simplifying in the brackets first, then you would have run into problems. Then you would have to modify the term again and again to try and get RHS, right? So rather than doing that, first reduce the term inside the bracket and then square it up, right? So that way you're going to get to RHS in less number of steps, right? Moving on, the fourth question of our day. Question number 4. Let's see what we have. Cos x minus cos y whole square plus sin x. It is negative. It's negative, sorry. Sin x minus sin y the whole square equals to 4 sin square x minus y by 2. Correct? That is something that you have to prove. Correct? Same thing right here. Before opening this squared bracket, try and reduce the term inside to be equal to something that RHS is, right? Let's try and do that. We'll write LHS and we'll try to simplify this. Right? I'm going to rub this off. Cos x minus cos y equal to minus 2 times sine x minus y by 2 x plus sine x plus y by 2. Correct? So I'll write that minus 2 sine x minus y by 2 sine x plus y by 2 ka whole square, plus similarly applying that same formula to sine, we get sine c minus sine d is equal to cos x plus y by 2 sine x minus y by 2 whole square. Correct? That is as simple as it gets. Now squaring these two terms up, I'll get 4 times. I am taking 4 times sine square x minus y by 2 as common itself in the same step, and let's try and get, because this right here and this right here is the same, right? So I'll try and take that common and see what I get inside, right? I've taken this out common, so what I'm left with here is sine square x plus y by 2 plus cos square x plus y by 2. Correct? Again, this is an identity, turns out to be 1, and what we finally get is 4 times sine square x minus y by 2, that is equal to our RHS as well. Very similar in pattern to the question that we had solved earlier, the third question, and so the solution was not very difficult, right? Moving on. Now this is something different and it's going to be interesting. Let's try and see how we get here. correct? We have to prove that sin x sin 3x plus sin 5x plus sin 7x equals to 4 times cos x cos 2x and sin 4x. Now, whenever you see questions of these type, try and figure out how you're going to take something out common, correct? Because that is what it is. When you take something out common, you can apply the formulation of sin c plus sin d, again and again, and you can reduce the term into a single term, right? Reduce all these terms into a single term. So that is something that you're going to think about while trying to solve this question, right? Try and look at this. X plus 7x equal to 8x. 3x plus 5x is also equal to 8x, right? So if I apply sin c plus sin d formula in these two terms and these two terms respectively, I am going to get sin 4x as common, correct? That is very simple for us to observe, because sin c plus sin d equal to 2 times sin c plus d by 2 cos c minus d by 2. So when I apply the same formula in both these two terms respectively, I'm going to get sin 4x as common, correct? So, and in the RHS as well, we see a sin 4x term. So that is something that you need to think along, and let's try and reduce that and see where we get, right? So applying the formula here, I'll get 2 times sin 4x, because sin c plus sin d is 8x by 2, correct? So that is just 4x, and cos, I'll get 7x minus x equal to 6x divided by 2 is equal to 3x, plus 2 times 5x plus 3x equal to 8x by 2 is equal to 4x. So sin 4x, and cos 5x minus 3 is equal to 2x divided by 2 equal to x, and cos x. These two terms are again common. Let's take them out. Get 2 times sin 4x cos 3x plus cos x, correct? Cos x sorry, cos 3x plus cos x is nothing but cos 2x, 2 times cos 2x cos x, correct? How do I get there? I get there by applying the formula cos x plus cos y. That's nothing but 2 times cos x plus y by 2 cos x minus y by 2, correct? The same c plus d formulas that I have been reiterating throughout the entire exercise. I'm going to apply them again, right? So I'll get this in the brackets. I'm going to get 2 times cos 3x plus x equal to 4x divided by 2 equal to 2x, cos 3x minus x equal to 2x divided by 2 equal to x, correct? 2 and 2 gets multiplied. What I am left with is cos x cos 2x sin 4x, and if you observe it properly, this is nothing but your RHS ka term, correct? This is your RHS. Hence the question is solved. So before solving questions of these accord, try and look at the term that is being built in the RHS and see if are there any specific formula that you could apply to the LHS, so you get something along the RHS ka lines, right? Try and formulate that in your mind, and that is how you're going to solve these questions, right? So moving on to the sixth question for the day. Question number 6, correct? Question number 6 says we need to prove that sin 7x plus sin 5x plus sin 9x plus sin 3x. So for our sake, they have also for the sake of understanding in this question, if I'm not wrong, they have also given us these brackets that explore along these lines. As I was reiterating to you again and again, try and think along how you're going to form the RHS term. And for the sake of we being able to do this question, they have already given to us the brackets that we need to explore solutions in, right? So in the denominator, I'm going to have something like cos 7x plus cos 5x plus cos 9x plus cos 3x, correct? This is something that I have. Now this I need to prove this equal to tan 6x. Correct. Let us start with the LHS term, right? Apply C plus D formula here. Sin C plus sin D is equal to 2 times sin C plus D by 2 sin C cos C minus D by 2. Correct. So when I apply this formula, 7x plus 5 is equal to 12x divided by 2 equal to 6x. I'll get sin 6x cos 7x minus 5 is equal to 2x divided by 2 is equal to x plus 9x plus 3x equal to 12x divided by 2 equal to 6x. So I'll get sin 6x again, and I'll get 9x minus 3 is equal to 6x. Get this term, right? In the denominator, I'll have 2 times cos 6x, right? And cos x. Well, how did I get there? It was very simple. I just looked at the term that I had here and plugged them in the formula of cos C plus cos D. Correct. Nothing, no rocket science here. So 7x plus 5 is equal to 12x divided by 2 equal to 6x. And because I had already solved that, I just plugged them into the cos function. Correct. I've done nothing else. Similarly, here, you can do that again. You can write cos 6x cos 3x. How did I do that again? Because I had already formulated 9x and 3x's addition and subtraction and dividing those 2 by 2, and I had already found this term and plugged them right into the formula, right? From the numerator and denominator, you can take 2 times sin 6x common in the numerator, 2 times cos 6x common in the denominator, and when you do that, you're going to have 2 times sin 6x, 2 times cos 6x, and in the numerator you're going to have cos 3x plus cos x. Same term, right? So as you can observe, these two terms are common in the numerator and the denominator as well. So we can cancel these two terms out. 2 and 2 also gets cancelled. Sin 6x by cos 6x is nothing but tan 6x, and that is nothing but RHS ka term. So the question is proved. Correct. When you are taking sin 6x and cos 6x common from the numerator and denominator respectively, you should this should come straight into your mind that the terms in the numerator and denominator must get cancelled, right? If they don't get cancelled, I won't be able to get tan 6x, right? So if they are not cancelling themselves out, they are doing something wrong, and try to reiterate what you're doing wrong and make corrections, right? In question number 7, we have to prove sin 3x plus sin 2x minus sin x equals to 4 times sin x cos x by 2 cos 3x by 2. Now try and do that again. Try and find out what is that specific term that when you apply to the formula, you're going to take something out common. Correct. That is the way that you should look at this question, right? So I have the term sin x right here. I do have it, right? Is there a specific way that I could take sin x out common? Let's try and think that. If I apply the formula of C plus D to these two terms, I get nowhere. I get nowhere because 2x minus x, that would be equal to x by 2. Correct. I'll get nowhere. If I apply sin C plus D to these two terms, then also I'm getting nowhere because 3x minus x. So I'm left with sin x, but the remaining term is sin 2x. So I'm getting nowhere, right? Again, if I apply to these two terms, then also I'm getting nowhere. So am I missing something here? The one thing that you might miss in this question is you need to expand sin 2x. That way you're going to take out sin x common, right? Let's try and do that. Let's apply the formula sin c minus sin d to these two terms and let's see what we get. So sin c minus sin d is nothing but cos c plus d by 2 cos and sin c minus d by 2. Correct. So 3x plus x equal to 4x divided by 2 equal to 2x cos 2x and sin 3x minus x equal to 2x divided by 2 equal to x. Plus, now don't write sin 2x as is because then you're not able to take anything out common, right? Instead, write sine 2x is equal to sine 2 times sine x cos x. Do you remember this formula? This was a formula that we studied long time ago, right? But this is the thing. You need to remember all these formulas if you're going to solve these questions efficiently, right? Take 2 sine x out common. So what we get right here is 2 times sine x common, cos 2x plus cos x. Correct. Now apply cos c plus cos d ka formula right here. You get 2 times sine x, 2 times 2x plus x equal to 3x. So cos 3x by 2, 2x minus 2x minus x equal to x divided by x divided by 2 equal to x by 2. Correct. 2 and 2 gets multiplied. At the end, what you are left with is 4 times sine x cos 3x by 2 cos x by 2. That is the thing. Correct. And that is equal to our RHS as well. And the question is solved. Correct. Moving on to the 8th question. Now, in the questions 8 through 10, we are going to calculate values. So rather than trigonometry, it could involve a bit of algebra as well, because it would involve some calculations. So I'm going to, skim through those calculations a bit quickly. So try and follow along the calculating stuff as I go along, right? In the 8th question, we are given tan x as equals to 4 pi minus 4 by 3 and x in second quadrant. Correct. Now, why is this important? Because we want to calculate the value of tan x by 2. And if we are not able to locate where x is, then we won't be able to ascertain whether x by 2 is positive or negative. Correct. How are we going to do that? X is in the second quadrant, right? So x is between pi by 2 and pi. Correct. So x by 2 should be in between pi by 2 and pi by 4, meaning x by 2 is in the first quadrant. In the first quadrant, tan is positive. So all instances of x by 2 are going to be positive. That is the first step towards solving the question. So if you are confused whether x by 2 is going to be tan x by 2 is going to be positive or negative, it's going to be positive. So if we arrive at such a conjecture in our question, we'll be able to solve it, right? That we know that tan x by 2 is positive. Correct. Moving on. Now I'll try and get. So when you're trying to solve x by 2's values, right? Try and get something along the lines of sine and cos, because sine and cos could be easily converted to their counterparts, right? Or you could even apply the formula of tan x by 2. Correct? That is something that you could also do. Let's try and do that. Could you write tan x as being equal to this? Could you write that? You could, right? And what was the formula for expanding tan x by tan x plus y? So tan x plus y was nothing but tan x by 2. Simplify this first, write this, plus tan x by 2 on 1 minus x by 2, correct, minus 4 by 3. That makes sense? So what I'll get is 2 times tan x by 2 minus 4 by 3 upon is equal to minus 4 by 3. 2 and 2 gets cancelled. What I'm left with is, now I'm going to start writing tan x by 2 as equal to y. Correct. I am going to assume that. Let us assume tan x by 2 is equal to y. Why do I assume that? I assume that because I'm going to solve a quadratic equation here. So that representation is going to help me solve it more quickly, right? Like that. So assume tan x by 2 equal to y. Assuming that you have y upon 1 minus y square equal to minus 2 by 3. Correct. Taking the negative sign here, I get y upon y square minus 1 equal to 2 by 3. Cross multiplying, I get 3y equal to 2 times y square minus 2. Correct. Taking these two terms out separate, I get 2y square minus 3y minus 2 equal to 0. And this is a quadratic equation, correct? Are you able to separate anything out of here? Are you? Yeah, you might be able to, right? In this particular exercise, you might be able to. So this is the quadratic equation that you're going to get. You're going to try and solve this. And when you solve this, the value of y that you're going to get is 2 upon root 5. Correct. You can try doing this as an exercise for yourself and see if you get there. Correct. Moving on to the ninth question. Or do you want me to solve this as well? I could like, I'll probably leave it up to you guys, right? You know the formula of how you can get the solution of a quadratic equation. You can just try doing that. Correct. Moving on to the ninth question. In the ninth question, I am given cos x equal to minus 1 by 3. Correct. Cos x equal to minus 1 by 3. X is in the third quadrant. Again, I'll do that because I need to find the value of cos x by 2. I'll assume x. I know that x is in the third quadrant. So x is less than 3 pi by 2 and x is greater than pi. So x by 2 is less than 3 pi by 4 but greater than pi by 2. So x is in the second quadrant. Answer is going to be negative. Correct, because cos is negative in the second quadrant as well. Correct. So just so we know that now. Oh, in this question as well, you are going to find out the value of tan x by 2 only, right? Okay, so maybe I've done something wrong here. We need to find the value of tan x by 2, cos x by 2, and sin x by 2 in all these questions, right? So in the previous question, I might have missed something. So let's try and do that, right? Let's solve the 8th question once again because I might have misread the question. So question number 8, we need to find the value of tan x by 2, sin x by 2, and cos x by 2 in this question, right? And need to find all these values, not just tan or sin individually, correct? And tan x is given to us as minus 4 by 3, correct? X in the second quadrant, correct? Now, when x is in the second quadrant, can we write this? We can, right? Because x is in the second quadrant. So when x is in the second quadrant, x by 2 is in the first quadrant. If x by 2 is in the first quadrant, tan, sin, and cos all are going to be positive. No doubt in that, right? We know the formula of tan x by 2. We do know that, right? Let us try and solve it using those lines. So tan x could be written as 2 times tan x by 2 upon 1 minus tan square x by 2. Because x could be expressed as being sum of x by 2 and x by 2, correct? So can I write 2 times tan x by 2, 1 minus tan square x by 2 as equal to minus 4 by 3. I can write that, right? Because I've expressed the formula of tan x by 2 earlier as well. I can cancel these two outs. I can now, for the sake of solving this quadratic equation, assume tan x by 2 equal to y. Correct. So I have y upon 1 minus y square equal to minus 2 by 3. I take the negative sign out common. I have 3y equal to 2 minus y square. That makes sense? Made some mistake in multiplying it. That's why I'm not able to get it correctly. So multiply minus 2 here, you get minus 2 and this is this, correct? So I get 2y square minus 3y minus 2 equal to 0, correct? Can I write this as this? I can, right? Taking 2y common, I'll get y minus 2 here. Taking 1 common here, I'll get y minus 2 here. Y is equal to 2. So tan x by 2 equal to 2. When tan x by 2 equals to 2, I know that sin x by 2 cos x by 2 equals to 2. Because I found the value of tan x by 2, correct? Now I know that x upon y equal to 2 upon 1. So x is equal to 2, y is equal to 1. So try and do that, right? If you construct a right angle triangle and you want to calculate the tan of this, height upon breadth is your tan, correct? So height is 2, breadth is 1 because tan x by 2 is 1. So this is root 5, isn't it? How did I get there? Because a square plus b square equal to c square, correct? So a square plus b square, that is 4 plus 1 equal to c square, and c would be equal to root 5. That makes sense. So when I have tan x by 2 as being equal to 2, I have sine x by 2 as being equal to h upon c, that is the hypotenuse, and the hypotenuse, the height is 2, hypotenuse is root 5. And similarly, this has become way too complex. I'll rub these things off. Similarly, cos x by 2 equal to 1 upon root 5. That makes sense, because cos x by 2 is nothing but breadth upon hypotenuse. And I already solved for hypotenuse. The hypotenuse is root 5. And that is it. So you have cos, you have tan, you have sine as well. This question is solved. Moving on to the 9th question. Sorry, it took so long. I got lost in between. Solve the quadratic. Made a mistake, so it took a bit time. But make sure you don't make these mistakes while solving this. Make sure you're solving your quadratics with confidence, and you'll get the answer quicker. Right. Moving on to the 9th question. You have cos x equals to minus 1 by 3, x in third quadrant. So 3 pi by 2, x greater than pi. So x by 2 is less than 3 pi by 4, but greater than 3 pi by 2. So x by 2 is in the second quadrant. Make sense? That doesn't make sense because it's less than 3 pi by 4, but it's greater than pi by 2. So sine x by 2 is positive. Cos x by 2 is negative. Tan x by 2 is also negative. Correct. We have found out all the signs. We're going to solve it now. We know for a fact that sine x by 2 equals to 1 minus cos sine square x by 2. Can you recall how I got here? Do you recall the formula of 1 minus cos 2x upon 2 as being equal to sine square x? Do you know this formula? I'm going to leave it here. I'm not going to solve it for you because this is something that you should know. If you don't know this, try and proving this. The hint is try and apply the formulation of cos c cos d. Try and do that. Cos c plus cos d. Try and do that. How do I get here from this to here? Try and solve that. But this is the formula that we are going to be using here. So doing that, I have sine square x by 2 is being equal to 1 minus cos x by 2. So I'm going to just use this, and cos x is nothing but positive. So this becomes this divided by 2. That makes sense. 1 plus 1 by 3 equal to 4 by 3. 3 comes into the denominator. I get sine square x by 2 as being equal to 4 upon 6, or that is nothing but 2 by 3. That makes sense. So sine is nothing, sine x by 2 is nothing but root 2 by 3. And because we know that sine is positive, so the sign here is positive. Similarly, if we solve for cos, we know the hypotenuse is equal to root 3, height is equal to root 2. So what is base? The base would be 1 because h square plus b square equal to c square, correct? 2 plus h square equal to 3. H is equal to 3 minus 2. H square is equal to 3 minus 2 is equal to 1. H is equal to 1. Makes sense? So the height is 1. So cos x by 2 is nothing but 1 upon root 3. That is breadth upon hypotenuse. Right, C, B upon C. Correct. And I've already solved for the breadth. The breadth came as being equal to 1. But what is the sign here? Because x by 2 is in the second quadrant, the sign is negative. That makes sense because x by 2 is in second quadrant and cos is negative in the same quadrant. So the cos x by 2 is negative right here. Tan x by 2 is nothing but sin x by 2 upon cos x by 2 and it's negative. So it's nothing but minus 1 upon root. Makes sense? I've done nothing. I've just divided. Wait, I did something wrong. It's minus root. Divide sin x by 2 by cos x by 2. Root 3 and root 3 gets cancelled. The sign changes and you get this. So you have sine, you have cos, and you have tan. The question is solved. Correct. Moving on to the last question that we have for the day. Question number 10. You are given sin x as being equal to 1 by 4 and x is in the second quadrant, right? X in second quadrant, it's going to be repetitive now, so I might pick up the pace. So x is less than pi, but greater than pi by 2. X by 2 is less than pi by 2, but greater than pi by 4. Correct. That, what does that mean? That means that x by 2 is in the first quadrant. In the first quadrant, sine, tan, cos, all positive. Correct. Nothing to worry about here. The sign is going to be positive for all of them. No need to worry about the sign. Right. Moving on. Third term that is given to us is sin x equal to 1 by 4. Whenever you see and when you want to calculate x by 2, make sure x by 2 formulations are in tan or cos because you have state formulas for using tan or cos. If you use sine, it's going to be very lengthy for you, right? So I'm going to first convert sin x into cos x. The hypotenuse is 4. The height is 1. What is the base then? The base is, so I'll use the formula b square plus h square equal to c square. C square is 4. C square is 4 square, that is 16. B square is something that you need to find out. H square is 1 ka square, which is 1. So b square equal to 16 minus 1. B is equal to root 15. And what is cos? Cos is nothing but b upon c. And we know for a fact that cos x is going to be, as x is in the second quadrant, so cos x is going to be negative here, not positive. X by 2, cos x by 2, sin x by 2, and tan x by 2, that may be positive, but cos x is negative here because x is in the second quadrant. Don't make the mistake here. You might end up with the wrong answer, right? So cos x is minus root 15 by 4. Do you get that? Because b we have found out and c we already had, and we know for a fact that cos x is going to be negative because x in the second quadrant. Correct. Now we have cos x. We can apply the same formulation as sine square x by 2 equals to 1 minus cos x upon 2. Correct. Using the same formula, sine square x by 2 upon 1 minus, this becomes plus because cos x is negative. Multiplying these two terms up, I get 4 upon root 15 upon is equal to 8. Now, the thing is, you could leave this term as is, but that's going to create complications for you when you're going to find out, sorry, what to put x by 2 here. It's going to create complications for you when you're going to find out tan x by 2 and cos x by 2. Rather than doing that, write sine square x by 2 as equal to 8 plus 2 times root 15 upon 16. I have done nothing but I have multiplied the denominator and numerator with 2. Can you write this 8 as being equal to root 5 ka square plus root 3 ka square, and this root 15 then becomes root 5 into root 3. Sine a plus b ka whole square formula is trying to turn up here, right? Could we write the numerator then as being equal to root 5 upon root 3 whole square, and this is equal to 4 square? Correct. Does that make sense? So sine then becomes sine square x by 2 then becomes this term, and you take root on both sides, you get sine x by 2 as being equal to root 5 plus root 3 upon 4. Correct. Now I found out sine x by 2 for you. Apply b plus c's formula and try to find out tan x by 2 and cos x by 2. I'm just going to write those answers for you, and you can verify them when you actually solve this. Correct. So tan x by 2 is going to come 4 plus root 15, and cos x by 2 would turn out to be 5 minus root 5 minus root 3 upon 4. Try to find out whether these answers are something that you get as well, because that is very important for you. But use these same formulations, b plus c's formulations, and you're going to get there, right? So that is all that we have for today. Thank you.